Hey guys, welcome to part 3 of my Boxing Bugs repair series. PCB repair. I am working on getting controls hooked up, and over here is the Boxing Bugs board set, and this is the controller port right here. It's a 26 position header. So I needed a 26 position plug. And I have a bunch of junk around, and I found this, which was a 26 position header, right? The only problem was it was connected to a 25 position cable, and I need that 26th wire. Number 26 is ground, so without number 26 it's no good. So I took that plug off of that and broke it in the process. I broke the little, it's hard to take those apart once they're crimped, but the little tab broke off, so I had to get creative, and I just soldered this together, and I think it came out pretty slick. I just folded down the pins, you know, I folded them outward, like flat, like this. They stand up like this. I folded them outward like that, and on the other side I folded them the other way so that they were flat, and then I tinned everything, and I clipped, like the top row is all odd numbers, like 1, 3, 5, 7, 9, and then the bottom is 2, 4, 6, 8 all the way to 26. So I clipped the even number wires about 1/8 short, you know, 1/8 of an inch shorter than the odd wires, so that they lay good like this. And you know, stripped them a little bit, tinned them, and soldered it. I think it came out pretty slick. I will hot glue this. I'll put hot glue over it to keep it good. But I think it came out really nice. And that will hook my controls up. So I'm going to go ahead and get to the rest of this, and I'll be back. Okay, I got this thing, you know, protected in glue and wired in to my harness, and those wires are so thin that I protected them with some hot glue so they won't pull up. And I've got the rest of the wires here for future if I need to connect anything. And there's a test mode on this, so I got that hooked up too. Yeah, so it's pretty elaborate. Coin switch right here. Got a coin switch. Yep. Pretty crazy harness. So let's hook this thing all back up now, see if it works. Okay, we are re-hooked up. And what I have found is all of my controls work, but not the encoder. So this is something, just a trackball, hooking a trackball up won't work. So I'm going to have to do a little research on that, on how that works. I'll probably ask Cop. I'll probably ask him about what he knows about it. But yeah, I got my coin switch in here. Check it out. Put in a credit, it gives you the bell, and it's saying press 1. Alright, I have the button for the boxing glove, panic, and I have the cannon. I can't spin though. Pretty cool. But yeah. Next round. Insert coins. What just happened? I don't know. Did it just weird out? What happened? Take that. How funny. Huh. Yeah, I don't know. I got to figure this out. I'm going to do some research on this encoder and see what's going on with it. I'll be back. Alright, I'm going through and programming a brand new set of software for this thing, because every now and again this thing will just get lost and reset. And you saw right then when I was messing with it, I was hitting the coin button, hitting start, and it wouldn't start and stuff. It was just, I have a feeling that the those ROM chips are just a little too far gone. I tried to clean them up and stuff, but I just don't think that there's hope for them, really. So I'm programming a nice brand new set of 2732s. And then we'll go from there. I've got the labels all made out. And it'll have a nice new set of software. And I think they're just flaky in it. I think the program gets lost a little bit and it resets, you know, so I got to do away with that. So these things take quite a bit. It starts at FFF and counts down like that. So these things take a little while to program. And what's funny about these is I bought these chips from China as see that? 2532A. These are 2732s. So if you buy 2532A like this from China and you try to program, they don't work, don't throw them out. They're probably 2732s. That's what I'm programming these as. And we are getting close. And it will verify. Data verification is correct. They are not 2532s. They are in fact 2732s. So be aware of that. Alright, I'm going to do the rest of these and I'll be back. Okay, I've got a whole set programmed here. But as I was removing these guys, I noticed this one up here, the power pin, pin 24, was bent and was barely making contact on the socket. So I checked all of the legs on every one of these, made sure that they went in good, and I've got it running right now, and I put a score up here, 2580 or something like that. And I'm just going to let this thing run. And if it resets, that score will be gone. I'm going to let it go for a while. I think it was just that bent pin. I don't think it'll flake out now. So, okay. I'm going to let it go and I'll be back. Okay, as you can see, I have taken that back off. And I have the Armor Attack ROMs back in the board. And I did this and turned it on at 7:45, and it is now, I don't even know what time it is. It's 8:49, 8:50. So it's been over an hour. And when I don't have the controls right for this game, but I did put credits in it. I put 5 credits in it when I turned it on because it kept resetting. Boxing bugs kept resetting. But you can see we have 5 credits still. This thing is just flaky with these ribbon cables and stuff. I hate to do this, but I'm going to do it because this is just not solid. These things suck. So when you've got problems like that with interconnects, then it is what it is. So what I'm doing is I'm studying the schematic for this. I'm going to use 2 27 128s in these 2 spots. I'm going to have 2 ROMs with all of that code because I've got, I mean, the heck on the back gives you the 2 address lines that you need. So I'm going to use 2 ROMs. What I'm doing right now is I'm putting, it's called concatenating or something like that. I'm putting all of the ROM files into one file, and I'm going to burn them into one ROM. And I'm going to set the camera up on the tripod and show you how I did that and kind of how I went about, because I had to figure out the decoding is what I had to do, you know, which was really straightforward and pretty simple. Come over here. These are the notes that I took while I was looking at the schematic. And these are the addresses. You know, 0 to FFF fires 1A, and it also fires 1A and B. Oh, I've got A on both of them. It's supposed to be B. It fires 1A and 1B. So that address is putting data onto both the odd and even bus on this game. You know, it's kind of weird how this, it's not weird, it's just how Cinematronics did it. They have 2 data buses. One, they call it odd data bus, and they call it the other one even data bus. And whenever you address a ROM, it basically puts 16 bits of data onto the bus because there's 2 data buses. It's not one data bus, there's 2 data buses. So what you need to do is put all of the A data together, starting from lowest to highest address, and then another chip, you'll have all of the B data starting from lowest to highest, and then that'll be 16K and 16K, and you'll burn that into a 127 or 128, 27 128, and you'll have 2 ROMs, and you can run the 2 jumpers, or you can run jumpers for the 2 address lines that are, you know, they're made in the hack. They're right there for the taking. So I'll set the camera up on the tripod and point it at the screen there and kind of go over it a little bit in the schematic. And then I'll show how I go about putting the ROM files together. So I'll be right back. Okay, we'll start with the schematic. This is that ROM board schematic. And okay. You see here it says even data bus. I'll try to blow it up. Here's even data bus, and that is the bus from the A side chips. See, they're all these but the data buses from these guys, from these A side chips, are all tied together, and they go to J3. And over here you'll see J3, so the even data bus goes to U7. See that? U7. So you put these files together and they'll go into the U7 socket. Now how you go about finding out what the addressing is, don't worry, and I hate how they did this. That's supposed to be address 0, and they started at address 1. So it made it really confusing for me. My brain did not like that. So you come up, and this is supposed to be address 12. See, 12, they got this labeled address 12, and it's going into address 11. Well, this is address 12 because they started at 1. You know, it made it really freaking confusing for me. I had to write out binary on the sheet and everything and kind of do it the way that they had it so that it wouldn't hurt my head. But if you go, you know, a 2732 is 0 to FFF on the range. So to figure out what ROM is fired at the address from address 0 to FFFF, or 0 to FFF, well, you have to look at address bit 12. Yes. Address bit 12 on up need to be 0. Address bit 12 is actually, see, it's getting me again. This is address bit 11. That's address bit 11. So 13 needs to be not 1, right? So that's 0. Address 14 needs to be not 1, so 0, right? So if this is 0, this is 1, right? So yeah, I'm confusing myself. These need to be 1. The knots need to be 1 because the actual addresses need to be 0. And then you have AND gates, NAND gates, I'm sorry. And this is another thing that you can look at when you're looking at schematics. How it's drawn will tell you how it works. Low output. To get a low output, you need 2 1s. You notice how there's no zeros on the end here? So if you have 2 highs, you'll get a low. The only way that this is enabled is if this is low. See, it's active low. So you need 2 highs, you need 2 1s on the inputs of these NAND gates. So the only way that you're going to get 2 1s on one of these NAND gates is if that's 0. If A14 is 0, because that'll be 1, right? And then the other one, 13, needs to be 0, because that'll be 1. So you have a 0 and a 0, 1, 1. And that will fire this guy. So 1A and up here is 1B are both fired from 0 to FFF. And then you can go on and figure, you can figure the decoding that way. But yeah, so that's that. And if we look at the odd data bus, which is these B chips up here, odd data bus goes into J2, and then we scroll over and find out where does J2 go. Here's J2. J2 goes to P7, so the odd data bus is out of socket P7, right? So, okay. I can tell you I already know what the ranges are, and I just did what I did finding this one out. 0 to FFF is these 2 chips. 1000 to 1FFF is these 2. And these 2 are 2000 to 2FFF. And then these guys over here are 3000 to 3FFF. So I'm putting from lowest to highest all of these files into one file and burning it into one chip, and then I'm going to take address bits 13 or 14. You can do away with all that not 13 and not 14 because there's no decoding. We're going to have address 13 and 14 directly hooked to the chip. And then over here, you know, it's the same thing. I'm going to have all of these, and these are the ones that I've already put these together. I'm going to show you putting these ones together into one file. So let's do that right now. I'll go ahead and close out of this, and I will open this hex editor that I like to use. So we'll open 1B, and I scroll it down. You can see it's to address 1000 or FFF. Always click on that and get that highlighted, and then minimize. Open up a new window and open up 2B, and edit, select all, right click, copy, and take the whole 0 to FFF, hit OK. So now we're copied, and you can just go ahead and close it. Open the new one back up. Make sure this is highlighted, because if it's not, it'll put it at the very top of the addressing. So just paste, and then always hit insert. Don't overwrite, and then boom, it just added 2B to that file. Come down. I always like to save it after I do one too. So that cursor is highlighted. That's good. Now we'll go back in, do another one, open up 3B. And same thing. Select all, copy. Okay. Close. Open this. Paste. Insert. Okay. And you can check, see how all these FFs are at the end of 3B. Sometimes I just like to open up that chip 3B and look at the very bottom and see all the FFs. See all them FFs. That way you know you're doing it right. So now we need 4B. 4B. Select all. Copy. Make sure that's highlighted and paste it. And insert. And I will save as, I'm going to call it P7. P7. Alright, now in my Boxing Bugs folder I have P7, which is 16K, and I have U7, which is 16K. Now I'll burn these into 2 chips, and then that'll go, over there. Good enough. We'll have Boxing Bugs in 2 ROMs. Eliminate that board. Eliminate those stupid ribbon cables and all of that. So let's get to it. All right. I've got my 2 chips burnt here. I got the 27 128s here, both files, P7 and U7. Here I have a print off of a 127 versus a 2732, 128. I keep calling this a 127. Okay, let's move this down to where it matches like this. Here we have address 7 all the way down, and then D012. Address 7 all the way down and D012. That's the same. Over here we have D3 up to D7, D3 up to D7. Chip enable's 20. Chip enable is 20. And yes, output enable, chip enable 20. 18 is chip enable. 18 Oh, that'll be in the socket. 18 over here, 18 is actually 20, right? Yeah. This is the way the socket goes. D3, enable, address 10, output enable, address 11, 9, address 8. And then this is VCC on the 2732, so we're going to have to lift the last 3 pins over here. We're going to have to lift the last 3. Well, these ones don't even go in the socket, but this one does. We can't have that in the socket. We have to lift that out. And over here, these 2 will be out. Of course, they're hanging out. They're hanging over the socket. So we will. This is programming voltage pin, which it'd probably be okay just to leave that floating, but I'm not going to. I'm going to tie that to 5 volts. I'm going to jump this over, tie it to this and this. So we'll have a jumper going from here, tying these 2 together, and then going to 5 volts to power this. And then we're going to jump address 13. Remember from the schematic where it has address 13? We'll find out where that comes off of the main board and goes up to that ROM board, and we'll tie that to this pin and to this pin. Address 12 to this one. Address 12 to this one, and 13 to this one. But on that schematic, it's called address 13 and address 14. Remember how they did that? But yep, that's what we're going to do. It'll be a little hacky with some wires and stuff, but you know what? It'll be solid. So that's all that really matters. So let's go ahead and get to it. Okay, so I have, there's P7 and U7, and you can see I've got pin 1, which is programming voltage, tied to VCC and program. So those are all tied high, right? And then I got that connected right here to 5 volts. But there's a new wrinkle that I did not foresee. I'm going to take this over and look at the schematic. I came over here to look at the schematic to find out, okay, where is address bits 12 and 13? Now, keep in mind, they're calling them 13 and 14 in this schematic, but it's really 12 and 13, which goes here and here. I'm like, okay, where is those coming from? And if you see, address 13 is coming from pin 18 of the socket. Pin 18 of the socket is actually output enable on this chip. It's pin 20 on this chip. It's chip enable. So they're using address bit 13 as an enable line on this. And address bit 11 is pin 21. That's the mod that's done, so that's good to go. But this is a wrinkle that I have to address, because address bit 13 is not supposed to be on pin 18 or pin 20 of this. That's actually pin 20. It needs to go right there. Nope, that's actually this guy right here. That's address bit 12. 13 on here is actually address bit 12. So what I need to do is I need to lift pin 18 and I need to ground it. I need to pull the pin out of the socket, and then I need to just ground pin 18. No, because that's pin 20. I just need to pull that. and run my address bit to it. Yeah. I need to... Okay, yes, I need to ground pin 20 on my chip. I just ground it. And then jump pin 18 over to pin 2. So this is only going to have one enable. The chip will always be enabled, but it will be fired by this signal, which is pin 20 on this guy, output enable. So we're going to ground the chip enable on our 128s. Lift the pin out of the socket, ground the pin, and then run a jumper from pin 18 in the socket over to address 12. Easier said than, I'll just do it on the back side of the board. I'll just run a little jumper from 18. No, I can't do it on the back side of the board. Maybe I can come up through the board somewhere. I'll figure it out. I'll be back. Okie dokie. And unplug that. This is what it looks like. We got pin 20 of the chip, which is actually 18. They had what was called address bit 12 going to that. So I just pulled that, grounded it, and then ran address bit 12 to where it goes right there. And then that's address bit 13. And I did drill a small hole in the board right there to fish these address lines through. And over here, that's grounded. And address 13, if we look at the schematic, let's go back over here, because I initially was about to do this wrong, because I was running pin 18 from this one up to address bit 13, and then pin 18 of this one over. No. It's only on P7. Address bit 13 is P7. The other one is not address bit 13, so that would have been wrong. So, and I'll show you that. There's only one address bit 13. But that's the only, that hole in the board is the only thing I had to do. I didn't change anything else as far as removing any of the mods that were previously done or any of that, See, here's where the address bit, this is address bit 13 going up. Address bit 13 comes off of here and goes up there. Address bit 12 that's pin 18 of P7. Address bit 13 is going up. That's the only changes on the back side. And I'm going to tack those down with hot glue. Make it look really nice. And pretty simple, straightforward. So let's plug this baby in. There we go, and turn it on and watch our light. 1, 2, 3. There you go, folks. Now this thing is solid and will be solid. Let's hook this thing back up. I'm going to remove the standoffs and let's hook this thing up. All right. We're hooked up without that ROM board. And look at that. How's about that? I think this is going to be a part 4, as we've done some cool stuff in this one, so I think I'm going to stop with this one, upload it maybe, and we'll come back to the testing. After this victory, I want to take a breath and stop for a minute. This was great. I really enjoyed doing that. And what I want to do anyway, while I'm uploading this, is I'm going to play a game. I'm going to put a score on here, and then I'm going to let it run and make sure that that score doesn't go away. I don't think it will. I think we're good to go because Armor Attack, when I had it up as Armor Attack, it went for an hour without resetting. But it would reset. The longest it went with that ROM board on it was about 30 minutes before it reset. So, and then other than that, it's, you know, 5 minutes, 10 minutes sometimes. You know, it didn't reset a lot, but it did reset. I know it did. So I'm going to do a nice run test on this thing right now and make sure there's no resetting. And I'll be back with part 4 with testing and stuff like that. Plus, I got to figure out the controls, the trackball. You know, I should be able to hook a trackball up to this, I think. So I got to figure that out. But yep, we'll see you on the next part.